Alright, good morning, sir. This is Kymani Richards, and today I will be presenting the 5 questions from the previous tutorial. Alright, so the first question states, what is the final pressure of a perfect gas that is heated isothermally from an initial state of 0.32 meter cube and 375,000 Newton meter square to a final state of 270 kilonewton meter square? Calculate the final pressure of the gas. Alright, so we know that the initial volume is equal to 0.32 meter cube, and the initial pressure is equal to 375,000 Newton meter square. Final pressure is equal to 270 kilonewton meter square, and the final volume is what we're trying to find. Alright, so with this form, so since I was trying to find the final volume and we have been given pressure and volume, we're going to use Boyle's law, which is a pressure law, which is P1V1 equal P2V2. So pressure 1 is initial pressure, which is 375,000 multiplied by initial volume, which is 0.32 meter cube, is equal to P2, which is, we can convert to Newton meter, which is 270,000 multiplied by X, which is final volume. Alright, let's go and transpose for X now. So we have 375,000 multiplied by 0.32 over 270,000. It's equal to X, and you can cross out X is equal to 0.44 meter cube. That's the answer. That's the volume. Alright, for question 2. Within an isobaric system of quantity of gas at 0.42 meter cube and 355 degrees Celsius undergoes process that causes the volume of the gas to decrease to 0.22 meter cube. Compute the temperature of the gas at the end of the process. Alright, so for this one, we know initial volume would be equal to 0.42 meter cube. Initial temperature is equal to 355 degrees Celsius, and I'm going to add 273 to that. Final volume is equal to 0.22 meter cube, and final temperature would be equal to x, because you're trying to find it. So with this question, we're going to use Charles' law, since our pressure is constant. So the formula is V1 over T1 is equal to V2 over T2. Now we're just going to plug in the values. So initial volume is 0.42 meter cube over temperature, which is 355 plus 273, which is 628 Kelvin, is equal to final volume, which is 0.22 meter cube over x. Now we're going to cross multiply. So 0.42 meter cube multiplied by x is equal to 0.22 multiplied by 628, which is 138.16. And cross divine transpose for x, so that is x equals 138.16 over 0.42, and x is equal to 328.95 Kelvin. You can see that the temperature decrease. As temperature decreases, volume also decreases. Alright, question 3. A sealed cylinder of gas at 0.056 meter cube is contained at a pressure of 400 kilonewton meter squared and a temperature of 55 degrees Celsius. The gas is compressed until the pressure reaches 2.27 meganewton meter squared and the temperature is 93 degrees Celsius. If the gas is assumed to be perfect, determine R is equal to 0.29 kilojoules per kilogram Kelvin. Find A, mass of the gas, and B, the final volume. Alright, so we know the initial pressure which is equal to 400 kilo Newton meter square. Initial volume, which is equal to 0.056 meter cube. Initial temperature, which is equal to 55 degrees Celsius plus 273. Converted to Kelvin We know final pressure which is equal to 2,270 kilonewton meter. Converted it from meganewton meter squared. Final temperature equal to 93 degrees Celsius plus 273. To convert to Kelvin, and we're trying to find final volume. X. Alright, so this we're going to use universal gas law, which is P1 V1 over T1 equal to P2 V2 over T2. Alright, then transpose now P1, which is 400, multiplied by V1, which is 0.056 over T1, which is 328 when I add 55 and 273 together, equal to P1, which is 2,270 multiplied by V2, which we're trying to find, over 366 when you add 93 and 273 together. Now I'm going to complete this side of the equation. Alright, when this side is worked out, the answer is 0.07, and we're going to move 366 to this side of the equation, so it's going to be a multiplication. So multiplied by 366 equal to 2270 V2. So when I work this out, I get 225.62 is equal to 2270 V2, and V2 equal to 25.62 over 2,270. Which is equal to V2 is equal to 0.011 meter cube. Alright, next part, mass of the gas. So the formula to find mass of the gas is PV equal MRT. I'm going to transpose for M, which is M equal PV over RT. So we have M equal to 2270 multiplied by the volume, which is 0.011 over the gas constant, which was given as 0.29 multiplied by the final temperature, which is 366, and all of that computed is 0.26 kilograms. Alright, question 4. Within an isochoric process system, 5.4 kilogram of a gas is heated at 0.94 meter cube and temperature 27 degrees Celsius until the temperature rose to 247 degrees Celsius. If the gas is assumed to be perfect, determine the heat flow during the process, the beginning pressure of the gas and the final pressure of the gas. And CV is given as 0.72 kilojoules per kilogram Kelvin, and R, which is the gas constant, is given as 0.287 kilojoules per kilogram Kelvin. So to find heat flow, the formula is Q equal to MC delta T, which is the change in temperature. So this is equal to Q, which was given as, no, not Q, M was given as 5.4 kilograms. C is 0.72. Multiplied by change in temperature, which when converted to Kelvin is 520. Subtract 300, and that computed is 855 joules. Our initial pressure. Formula is PV is equal to MRT, and I'm going to transpose for pressure. So P is equal to MRT over V. So P is equal to 5.4, which is a mass. R was given as 0.287. And changing, and temperature is 300 Kelvin over volume, which is initial volume, 0.94. That computed is 494.6 meter cube. Alright, final pressure now. I'm going to use the universal gas law. P1 V1 over T1 is equal to P2 V2 over T2. I'm going to transpose for P2, which is P1 V1 T1 over T2 V2. P2 is equal to 496, which is pressure 1, 494.6, which is pressure 1, multiplied by 0.94, which is volume 1, multiplied by 520. which is temperature 2 over 300 Kelvin, which is temperature 1, and 0.94 meter cube, which is volume, and that computed is 857.31 meter cube. No. Sorry, not meter cube. Newton meter square. Alright. Final question. Calculate the following for a certain perfect gas. A, the gas constant, and B, the molecular weight of the gas. And given is constant pressure, which is 0.846 kilojoules per kilogram Kelvin, and constant volume, which is equal to 0.657 kilojoules per kilogram Kelvin. Alright, so find gas constant. The formula is R, which is symbolized for gas constant. R is equal to constant pressure minus constant volume. That is 0.846 subtract 0.657, and R is equal to 0.189 kilojoules per kilogram Kelvin. Alright. Now finding molecular weight. So the formula for molecular weight is M equal to universal gas constant, which can be RO or RU. We use RO over gas constant, what we just found out. That is equal to 8,314 over 189. That is equal to 44 kilogram. Alright, that's it.